Hello everyone, I hope you're okay. This is the fourth video, guys, from answering the past question papers for in acids and bases. Okay, we are told that the balanced equation below represents the first step in the ionization of sulfuric acid. Okay, and we are told that okay, we are given, excuse me, we are given the balanced equation. Yeah? The first question says write down the formula for two bases in this equation. This guy is an acid because whenever you consider the forward reaction, it donates a proton. It started with H2SO4, ended up with HSO4, right? But this one is the base because it started with H2SO4 and ended up with H3O plus. So the H2O rather accepted a proton for it to become H3O plus. And then whenever you focus on the reverse reaction, H3O plus will become H2O by giving away a proton. So this one is an acid now. Are you together? And then HSO4 minus will become H2SO4 by accepting a proton. This will become a base. So the two bases in this equation are H2O. The second one is HSO4 minus. Okay, is sulfuric acid a strong or weak acid? Give a reason for your answer. Sulfuric acid is a strong acid. Why? Because it ionizes completely. Okay, learners use the reaction of a 0.15 moles per cubic decimeters of sulfuric acid with a sodium hydroxide solution in two different experiments. Okay, the balanced equation for this reaction is as follows. Okay, in the first reaction, they use 24 cubic centimeters of the acid in a titration to neutralize 26 cubic centimeters of the base. Calculate the concentration of the sodium hydroxide. They said they use 24 cubic centimeters to neutralize the base. That means there's complete neutralization in the first experiment. So we can simply use our titration equation. Ca multiplied by Va over Cb. Okay. The concentration of my acid, I know that's 0.15. The volume that they use is 24 cubic centimeters. And the concentration of my base, that's what I want. The volume is 26. And then Na and Nb, please guys, remember that always Na does not represent the number of moles of substance A, and Nb does not represent the number of moles of substance B. It simply means it is simply taking the stoichiometric coefficients. Are you together? Since this was my substance A and this was my substance B, the stoichiometric coefficient for A is 1. The stoichiometric coefficient for substance B is 2. The only unknown, guys, is the concentration of my base. So how can I find the concentration of my base? Yes, I can cross multiply, and then I'll later have 0.15 multiplied by 24 multiplied by 2 all over 26. So therefore the concentration of my base, let me punch my precious calculator, 0.15 multiplied by 24 multiplied by 2 divided by 26. I'll get 0.2769 etc. So I'll just round it off to 0.28 mole per cubic decimeter. So that's my concentration, guys, of the base. Okay, so the concentration of my base is 0.28 mole per cubic decimeter. Okay, following question. We are told that in another experiment, let me erase here. In another experiment, 30 cubic centimeters of the acid is added to 20 cubic centimeters of the base solution in a beaker. Calculate the pH. Okay. Remember that, guys, the pH of the solution will only be determined by the substance which is in excess, right? Since we are not told that in this experiment there was complete neutralization, please refrain from using the titration equation, right? Rather, let's go to the basic calculations of chemistry. Find the number of moles for the acid, find the number of moles for the base, determine between the two which one is the limiting reagent and the reagent in excess, and then calculate the number of the ions in excess, then find your pH. Okay, for my acid, I'll simply do this. The number of moles, I don't know which acid I'm using. It's H2SO4, né? The number of moles of H2SO4, concentration multiplied by volume, né? That's simply, the concentration is 0.15, the volume is 0.03. Please, guys, whenever you use this formula, you must always convert our volume into cubic decimeters. 0.15 multiplied by 0.3, I'll simply get 0.045 moles. These are the number of moles of my acid. Let me now calculate the number of moles of my base, NaOH. Concentration multiplied by volume. The concentration is 0.28. The volume is 20 cubic centimeters, 0.02. 0.28 multiplied by 0.02. I simply get 0.0056 moles. Okay, and then now I simply need to find out which one between the two is my limiting reagent. The limiting reagent, guys, please remember that is always the substance that will give me the smallest amount of products. So for acid, let me use red for acid. I know that 1 mole of sulfuric acid will give me 1 mole of sodium sulfate. Together, but now I have 0.045 moles. Is it 0.0 or 0.00? Let me 0.03 times 0.15. Yeah, it's 0.0. I omitted the 0 there, guys. Excuse me. It's 0.0045. I want to know how much of the sodium sulfate will I form. This is the sodium sulfate, my product. I'll simply cross multiply, then X, which represents the number of moles of the sodium sulfate which will be formed if I have to use my acid completely, will be 0.0045 moles. Okay, and then let me check for the base. I know that 2 moles of my sodium hydroxide will give me 1 mole of sodium sulfate, but now I have 0.056 moles. I want to know how much of the sodium sulfate will I form. Just cross multiply. I will have 2x is equal to 0.0056. Then x will be 0.0026 moles. Remember that x represents the number of moles of sodium sulfate which will be produced if I had to use the sodium hydroxide completely. Okay, we can all see that, guys. We can all see that the sodium hydroxide is my limiting reagent. Why am I saying that? Because it gives me the smaller yield of the products. Are we together? Sulfuric acid gives me 0.0045 and sodium hydroxide gives me 0.0026. So sodium hydroxide is my limiting reagent. Are we together? So this thing simply means that the acid, sulfuric acid, is the one in excess. So the pH will be determined by the reagent which is in excess. Keep that in mind. Since sulfuric acid, guys, is in excess, I think it's safer for me to write down the ionization equation of sulfuric acid. Sulfuric acid ionizes in water to donate 2 protons plus SO4 2 minus. Just for the balancing of the equation, I just need to place a 2 there. Okay, since I know that, guys, my sodium hydroxide will be completely used up, I want to know how much of the sulfuric acid. I know that 1 mole of sulfuric acid will completely react to 2 moles of sodium hydroxide according to this equation. Are you together? But now I do not have 2 moles of sodium hydroxide. I have 0.0056. I want to know how many moles of the acid will I need rather. So I'll just cross multiply. I'll have 2x is equal to 0.0056. Then x is equal to 0.0023. What did I write 26 there? Hey, let me cut 0.0056 divided by 2. I'll pretend as if it's my bad handwriting. Yeah, it's 28 there. Okay, so this is the amount of acid that I will use for me to completely react with the base. Are you together? So therefore, to find the number of moles of the acid which are in excess, I simply need to say number of moles in excess is simply equal to the number of moles initial minus the number of moles which were used, or the ones that reacted with the base. Initial at 0.0045, and then I'm subtracting the ones that I've used, which is 0.0028. So 0.0045 minus 0.0028, what do I get? 0.0017 moles. So these are the number of moles of my acid which are in excess. Are you together? So all I need to do now is to find out is to calculate the concentration of the hydronium ion, and then later find the concentration of and after finding the concentration of the hydronium ion, I'll simply calculate the pH after that. But before I find the concentration, it is much safer for me to calculate the number of moles which are there for, or the number of hydronium ions. I know that H2SO4 will give me 2 H3O plus ions. But now how much of the acid do I have in excess? 0.0017. I want to know how many hydronium ions will I form. I'll simply have 2x is equal to 0. No, not 2x rather. X, which represents the number of H3O plus ions, is simply 2 times 0.0017, which will give me 0.0034 moles. Alright, together. So for me to find the pH, I must find the concentration first. So therefore, concentration of my H3O plus ions, number of moles over volume, it's simply 0.0034 divided by the total volume of the solution. Remember that I've added 30 cubic centimeters and 20 cubic centimeters of both the acid and the base, respectively. So the final solution has a volume of 50 cubic centimeters. That's 0.05. So my concentration 0.0034 divided by 0.05. My concentration will simply be equal to 0.068 mole per cubic decimeters. 68 mole per cubic decimeters. So therefore, the pH, guys, is equal to the concentration of the H3O plus minus the log of 0.068 minus the log of 0.068. I get 1.17. So this is the pH of the solution. The first thing I did, guys, this work was tedious, no? However, the first thing that I did, let me number this in green, was to find the number of moles of the acid. Secondly, number of moles of the base. Then after that, I had to identify rather my limiting reagent. Are you together? This step here, I was just identifying the limiting reagent. So when I know which substance is the limiting reagent, I will know that which one. I will simply know which one is in excess. Are you together? The sodium hydroxide was a limiting reagent because if it was completely used up, it would give me the smallest amount of product. So sodium hydroxide was the limiting reagent, which makes sulfuric acid to be the reagent in excess. Are you together? So since I know that sulfuric acid will be in excess, I know that the excess moles of sulfuric acid are the ones that will determine the pH of the solution. Are you together? Okay, and then I simply wrote down the ionization of sulfuric acid, and then I calculated the number of moles which were in excess. I got 0.0017. After doing that, I calculated the number of moles of the hydronium ions which were produced by the acid in excess. I got 0.0034, and then calculated the concentration of my hydronium ions. This is what I got, and then later found the pH. Yeah, get on, but the 8 marks, guys, we must take it all. We must take all of it. So this is how, guys, we're supposed to deal with this calculation. I hope, guys, it makes sense. If you need further explanation, please, guys, ungasabi ukusho kuma comments. I'm here. Sharp. Wait for the other video.